You might imagine that Earth is like a giant spinning basketball in space. If this was true, the wind currents would be the same all around the Earth and would never really deviate from traveling in a straight line. Let's learn why this isn't quite true and the reasons why. The first reason has to do with how air rises and descends on different parts of the globe. Because the Earth is tilted on its axis, the most direct rays of solar energy hit the equator. You can see here. Because that part of the globe sticks out the farthest, it is always in the closest proximity to the sun. Solar rays are less intense above and below the equator because the solar energy is less focused in those areas. Because of the difference in the intensity of solar energy on different parts of the globe, temperatures and climates vary depending on what latitude you are in. For example, at the top of the troposphere, half of the air moves towards the North Pole and half towards the South Pole. As it moves along the top of the troposphere, it cools. The cool air is dense, and when it reaches a high pressure zone, it sinks to the ground. The air is sucked back toward the low pressure at the equator. This process describes what we call convection cells north and south of the equator. And you can see here those different kinds of cells. There are 3 types, and you can see them. They're polar cells, Hadley cells, and Ferrel cells. And like I said, because of the different climates, each cell will produce a different pressure system, and they will all have different directions of airflow. Between 0 and 30 degrees is what we call Hadley cells. The air here should move north to south, but it's deflected to the right by the Coriolis effect. So the air blows from northeast to the southwest. This belt is called the trade winds. It was called that because at the time of sailing ships, they were good for trade because of how the air blew. Between 30 and 60 degrees is the Ferrel cells. Here, air should move south to north, but the winds actually blow from the southwest. This belt is the westerly winds or the westerlies. And between 60 and 90 degrees is what we call the polar cell. Here, the winds travel from the northeast and are called the polar easterlies. The wind belts are named for the direction from which the winds come. The westerly winds, for example, blow from west to east. These names hold for the winds in the wind belts of the southern hemisphere as well. So, now we're going to talk about what the Coriolis effect is. If you look here, you see this spinning merry-go-round, and I think it's a pretty good way to explain. Just give me a second. This Coriolis effect determines that moving air masses in the northern hemisphere veer to the right. It's caused by the spin of the Earth, and it's also the opposite in the southern hemisphere, so moving air masses would veer to the left. The Coriolis effect is really just a fancy optical illusion. The wind isn't actually deflecting from its straight path, but it appears to do so because the ground continues to move beneath it. So if you think of yourself riding on this merry-go-round, and while you're riding it, you're aiming an arrow at a target. Even if you were perfectly lined up to hit the bullseye, by the time you released the arrow and it traveled through the air, it will have veered to the right or left, depending on what direction you were spinning on the merry-go-round, and you will end up not hitting your target. This is an example of how the Coriolis effect can deflect wind patterns around the Earth. And lastly, we're going to talk about how the general circulation impacts the climate in some areas of the Earth. So we talked about how there are different regional and seasonal wind patterns. High pressure systems, they tend to form on land during winter months, and low pressure systems can form on land during summer months. When this pair of phenomena dominates in an area, a monsoon pattern is created. So a monsoon pattern occurs when summer low pressure systems pull in the warm, moist air from the oceans, and that creates rainy climate on the land. The winter high pressure systems push away moist ocean air with dry air from the land. So this pattern is best known in southern Asia, like India and Bangladesh, but it can also occur in the southwest US, and it can produce very violent and dangerous weather. Finally, the high and low pressure areas created by those 6 atmospheric circulation cells generally determine the amount of precipitation a region receives. In low pressure regions where air is rising, rain is common. In high pressure areas, the sinking air causes evaporation and the region is usually dry. Thanks for watching.